All right, welcome back to another lecture. In this one, we're going to discuss section 1.7, which is about measures of center of grouped data. And we've talked about measures of center before, measures of center being mean, median, and mode. And there are other measures of center, but those are kind of the big three, mean, median, and mode. And so in this section, what I want to do is go through and talk about how we would compute measures of center if you have grouped data, which may be kind of like an ambiguous term to you right now, but you'll understand what we're talking about as we go along. Basically, what I want you to be able to do is when you're looking at a graph, like a histogram or a bar chart or something like that, I want you to be able to make sense of that graph. I want you to be able to look at it and be able to determine what the mean, median, and mode would be of the distribution. And I don't mind saying kind of right at the outset that, I kind of hesitate to cover this particular block of material because, there's so much that we could discuss in an intro stats class that you really just kind of have to pick and choose the things that are going to be the most important. And I'm not totally sure that this really rises to the level of the most important thing, but there are a couple reasons why I want to cover it. The first is, as I said a second ago, I want you to be able to make sense of graphs. As you're looking at graphs, I want you to have a good feeling for what the typical value in the data set is, okay? And in my experience, I think that for some of you, that's a very intuitive thing. And so you may not even need this section, but for a lot of you, in my experience, this is not not an intuitive thing, and you kind of need a little bit of guidance to help inform your intuition. And so anyway, that's what this section is about. But the second reason that I want to cover this material is because the way that we calculate measures of center from grouped data is very similar to the way that we compute something called the weighted mean. And the weighted mean is actually very important to your life as a student. Your GPA, for example, is a weighted mean. And so I just think that for your life as a student, it's important for you to understand a little bit about weighted means, and therefore it just makes sense to talk about measures of center of grouped data. So my goal here is to take as an intuitive of approach as I possibly can, and not just throw a bunch of nasty looking formulas at you. So that's kind of the goal. We're going to try to avoid getting into the weeds too much, and just hopefully develop our intuition surrounding this topic. As always, before we get started, make sure that you have downloaded the notes so that you're ready to take notes. There's no data set for this particular section, so you don't have an Excel spreadsheet, with data on it to download. That said, the apps from Art of Stat might come in handy, so go ahead and have those ready to go. Especially the Explore Quantitative Data, that might come in handy, and of course a calculator. So if you don't have a handheld calculator, go ahead and open up the Desmos Scientific Calculator so that you're ready to go, and let's dig in. So if you're looking at a graph of some categorical data, so if you're looking at a bar chart, then calculating measures of center is very simple, because if you have categorical data, the only measure of center that you can compute is the mode. And the mode is very easy to see from a bar chart, as we discussed in the previous section, right? So in this particular case, we have injury locations. We've seen this example a couple times, and we're asked to calculate the mode of the data. Well, clearly the mode is back, right? That's the observation that occurs most frequently. So mode equals back. Okay. You weren't asked to compute the mean and the median, and I think there's a follow-up question here that asks why, right? Why didn't I ask you to calculate the mean or the median? Well, because this is categorical data. And it's not possible to compute the mean or the median, right? This graph gives us a summary of the data set, right? And so you might get confused and say, well, isn't this like 12 and 2 and 1 and 2? And so you might be tempted to say, well, the mean would be 12 plus 2 plus 1 plus 2 and so forth, and then divide by the number of injury locations or something like that. But that's not correct. If you're thinking that, you're getting the frequencies mixed up with the actual data itself, right? The data itself would have been back, right? 12 times. And then wrist, wrist. I'm not going to write it all out, but you get the point, right? This is what the actual data would have been. You can't compute the mean of this, right? It wouldn't make any sense, right? Back plus back plus back plus back plus wrist plus elbow plus wrist plus hip. I mean, you can't actually add up words. Okay, you can only add up numbers. So you can't calculate the mean, can't calculate the median, because this is categorical data. So why didn't I ask you to calculate the mean or the median? Because this is categorical data. So computing mean and median is not possible. Okay, so that's it for categorical data. Pretty straightforward. Let's talk about numerical data. Here things get a little bit trickier, but hopefully not too terrible. Okay, the name of the game is to correctly identify where your categories are and where your counts are, and we already kind of saw that. So in this example, we're asked to calculate the mean, median, and mode of the data in the graph below. And this data is supposed to represent the number of chocolate chips in Quiznos cookies. So on the x-axis, I guess we have number of chips. And then on the y-axis, as usual, we have the frequency, or you could also call it the number of cookies. So, for example, there were, it looks like 11 cookies that had 23 chocolate chips in them, right? And there were 20 cookies that had 24 chocolate chips in them, and so forth. Okay, we're asked to compute the mean, median, and mode of this data. Well, the mode is pretty clear, right? It's going to be 24, right? That was the number of chocolate chips that occurred most frequently. Most of the cookies had 24 chocolate chips in them. So the mode is 24. Whoops. So mode equals 24. So far, so good. Now, as far as the mean and the median are concerned, this time we do have numbers, right? We do have numbers. So we can, in this case, we can compute the mean and the median of this data set. And probably the easiest way for us to get our heads around how we can do that would be to just start to list out what the original data set would have looked like, right? So the original data set would have had 11 23s, and then 20 24s, and then 9 25s, right? So it would have looked like 23, 23, 23, 11 times. This is the data, by the way. I'm not actually doing any calculation. I'm just trying to list out what the original data set must have looked like, right? So it would have had 11 23s, and then it would have had 20 24s. So 24, 24, 24. And that would have occurred 20 times. Okay. And then it would have had 9 25s. So 25, 25, 25, 9 times. Okay, so if I want to compute the mean and the median of this, well, one way that I could do that would be I could go over to the Explore Quantitative Data app, and I could enter my own data, and I could just punch in those values, right? I could type in 23, 23, 23, 23, right, 11 times, and eventually, I don't know what error is going on here, but eventually it would calculate the mean and the median for me. But I think a quicker and easier way to do that would just be to do some of this work by hand, right? So for the mean, for example, right, the sample mean x bar, to calculate this, what I would want to do is add up all of the values and then divide by the number of values, right? So I would add up 23 plus 23 plus 23, right? And I would want to do that 11 times. And then plus 24 plus 24, right? Plus 24. And I would want to do that 20 times. And then I'd want to add plus 25, plus 25, plus 25, and I'd want to do that 9 times. Okay, and then I would want to divide by the number of values. Well, as we've stated a few times already, there are 11 23s, 20 24s, and 9 25s. So the total number of values would be 11 plus 20 plus 9. Okay, let me write this in a slightly different way. Instead of doing 23 plus 23 plus 23 11 times, we could just say, if you add 23 to itself 11 times, that's just 23 times 11, right? So we could just call this 23 times 11. And the same with the 24, right? We would say plus 24. If we add 24 to itself 20 times, that's just the same thing as saying 24 times 20. Okay? And then the same thing with the 25. If we add 25 to itself 9 times, that's just the same thing as saying 25 times 9. Okay, and then 11 plus 20 plus 9. And now if you head over to the Desmos calculator and you type this into the calculator exactly the way it looks, it'll spit out the correct answer for you. So let's go ahead and do that. So in Desmos, first of all, I'm going to give myself a little fraction bar, and then I can type in 23 times 11 plus 24 times 20 plus 25 times 9, and then arrow down and do 11 plus 20 plus 9. And there you go, 23.95. That's the average number of chocolate chips per cookie, right? 23.95. Okay, so that's how we would get the mean. The median would be, if we wanted to compute the median, we would also want to list out the data like we did earlier, okay? And then remember, the median is the middle value. So it would be whatever value is in the middle of this list. And I think you would agree with me probably that the number that's going to be in the middle of this list has to be 24. Okay? Because in total we have 20 plus 11 plus 9, which I think comes out to 40 cookies in the data set. Okay, 40 cookies in the data set. So the cookie that's right in the middle would be in position, between position 20 and 21, right? Between position 20 and 21. Well, so if I count up from the bottom, right, I would have 11 23s, and then I would have 9 more 24s to get to the middle position, but I would still be here in this group of 24s, right? If I'm trying to find like the slot that is right between the 20 and 21st positions, the 20th and 21st position, it would be in this group of 24. So clearly the median is going to be 24. Okay. And so that's how we would compute the mean and the median. Uh, so let's look at another example. Let's make this, let's take this up to the next level. And this next example is going to be kind of the most challenging. But in that previous example, we didn't have our data grouped into classes. And so it was fairly easy, right? With a little bit of thought, we were able to list out what the original data set looked like. If you're dealing with a case where the data have been grouped into classes, then it's a little bit trickier because you can't recover what the original data set would have looked like. Looking at number 3, for example, this histogram is supposed to represent the commute time to work of a bunch of employees. And this first bar right here represents all of the employees who had a commute time between 0 and 5 minutes. And there was only one of those, okay? But we don't know what their exact commute time was. It could have been 2 minutes. It could have been 3.5 minutes, right? All we know is that it was somewhere between 0 and 5 minutes, okay? So we don't actually know what the what the original data value was. And consequently, when we're giving the mean or the median of a data set like this, we just have to give kind of our best educated guess, okay? Similarly, there were 2 people that had a commute time between 10 and 15 minutes, but we don't know what their actual commute times were. It could have been that they both had an 11-minute commute time, or it could have been that one of them had a 12-minute commute time and the other one had a 14.5-minute commute time. We just don't know. So our best guess in this case, right, is going to be to just use the class average as our best guess, right? So again, the person here had a commute time between 0 and 5 minutes. We don't know exactly what their commute time was, but probably the best guess is the number that's kind of right in the middle, right? The average. So the number that's right in the middle between 0 and 5 is 2.5, right? That would be kind of our best guess of the commute time of that person. And in a similar way, probably the best guess of this person here who had a commute time between 5 and 10 minutes would be the number that's right in between 5 and 10, which is 7.5. And if it's not immediately intuitive to you how I'm getting that number, you could just find the average. 5 plus 10 is 15. 15 divided by 2 is 7.5. And feel free to use your calculator to do that, right? So the best guess for the commute times of these 2 individuals who had a commute time between 10 and 15 minutes, the best guess would be 12.5, right? Because 10 plus 15 divided by 2 is 12.5, right? That's the number that's right in between 10 and 15. These people, the best guess is that their commute time was 17.5, and for these people, the best guess is that their commute time was 22.5. Okay. So once you've given these kind of like best guesses of what the commute times are, well, then you can go back and find the mean and the median in exactly the same way that we did example 2, right? Essentially, we're going to say that there was one person who had a 2.5 minute commute time, one person who had a 7.5 minute commute time, 2 people who had a 12.5 minute commute time, 6 had a 17.5, and 5 had a 22.5 minute commute time. Okay, and so then you can go back and you can compute the mean and the median exactly the way that we did before. So I will let you pause the video and see if you can work that out like we did example 2. Here are my solutions. So for the first of all, like if it's helpful, you can just kind of write out what the data set would have looked like. And again, we don't have the exact values, so this is just kind of like a guess. But our best guess is that the data set would have been 2.5, 7.5, 2 12.5s, 6 17.5s, okay, and then 5 22.5s. And I think once you have kind of the data set written out like this, finding the mean and the median is not too terrible, right? So for the mean, x bar, here I'm going to use an approximation sign because, again, this is just kind of our best guess. It's an estimate, so it's maybe not exactly the value of the sample mean. But what we would do is add up the values in the data set and then divide by the number of values in the data set. So we're going to add up the values, 2.5 plus 7.5 plus 12.5 times 2, okay, because we add it to itself, plus 17.5 times 6, because there were 6 of those, plus 22.5 times 5, okay, because there were 5 of those. And then we're going to divide by the number of values in the data set, which would be 1 plus 1 plus 2 plus 6 plus 5. And then we can punch that into our calculator. Okay, give yourself a little fraction bar, and then we do 2.5 plus 7.5 plus 12.5 times 2 plus 17.5 times 6 plus 22.5 times 5, arrow down, and then 1 plus 1 plus 2 plus 6 plus 5. And there you go. If we round this off to one decimal place, we would say it's about 16.8. Okay. So this is about 16.8. Okay. And then as far as the median is concerned, for the median, we just need to try to find the number that's right in the middle of the data set. So to do that, first of all, we should figure out how many values are in the data set. 6 plus 5, so 6 plus 5 is 11, plus 2 more is 13, 14, 15. So 15 values in the data set. So the value that's going to be right in the middle is going to be in position 8. Okay, position 8, because then there are 7 values below it, 7 values above it. So let's see if we can count up to position 8, right? We would have position 1, 2, 3, 4, and then 5, 6, 7, 8 puts us in this group right here. So the median is going to be 17.5. Okay. As a bonus question here, we could ask which of those measures of center, 16.8 or 17.5, is a better measure of center for this data set? And we would say 17.5 because this data set is skewed, right? So remember, you use the mean for a symmetric data set, the median for a skewed data set. So 17.5 is a better measure of center for this particular data set. Anyway, so that's number 3. Here's something worth pointing out. So this is the formula that we usually give to students to calculate the mean for grouped data. If this formula scares you, then just forget about it. Don't worry about it. Just use the intuitive kind of understanding that we've developed over the last couple of examples to compute means from grouped data. But just to give you an idea of what this formula is trying to communicate to us, it's saying, well, if you want to compute the mean from grouped data, what you should do is take the class average, okay, that's xi star, that's the class average, and then multiply that times the number of times that class occurred. Okay, that's fi, frequency, right? It's the frequency of the ith class. And then you should add those up. Well, look, that's exactly what we did, right? We took the class average of the first class and multiplied it by 1. We didn't write that down, but 2.5 times 1 is still 2.5 because there was only one copy of the 2.5s. And then we did the same thing with 7.5, right? We took the class average and multiplied it by its frequency. And then we took the class average here, multiplied it by its frequency, right? That's this little chunk. And then we took the class average here and multiplied it by its frequency. Okay, that's this little chunk. Okay, so this is what we're doing. And then we're adding all of those up, right? So we're taking each class average, multiplying it by its each class average, right? Multiplying it by its frequency, and then we're adding those up. Okay, and then we're dividing by the sum of the frequencies. Well, again, that's exactly what we did, right? That's exactly what we did. The frequencies were 1, 1, 2, 6, and 5, and that's what we're dividing by. We're dividing by the sum of those frequencies. Okay, so again, if the formula scares you, then don't worry about it. But that is mathematically how we would encode exactly what we did on the previous example, right? The reason that I explain that to you and give you that formula is because this formula is exactly the same way that we would compute a weighted mean, which is a slightly different concept, but it turns out to be mathematically equivalent to finding the mean from grouped data. So let's talk about the weighted mean. As I kind of led with at the beginning of the lecture, for your lives as students, the weighted mean might be the most important topic we cover all semester. It's not necessarily the most important topic, after you graduate, but at least while you're a student, you'll be dealing with weighted means quite a bit, because for most of the classes that you take, your grade in the class is going to be a weighted average, right? Because tests are not worth the same amount as homework. Tests contribute more towards your grade than the homework does. So, in order to figure out what your grade in a class is, you have to perform a weighted mean. Now, granted, Canvas will do those calculations for you, so you're not actually doing the computations yourself. But if you want to understand what Canvas is doing, then you have to understand a little bit about weighted means. Similarly with your GPA, right? Your GPA is going to be a weighted average because not all classes are the same number of units. Your 5-unit biology class is going to contribute more towards your GPA than your 3-unit communication class, right? So anyway, so here's the formula for the weighted mean. And you can see that it looks very similar to the formula for the mean from grouped data that we just went over, right? Instead of doing the class average times the frequency, we're doing the, sort of like the class average times the weight of that class. And then instead of dividing by the sum of the frequencies, we're dividing by the sum of the weights. Okay, but otherwise, it's exactly the same thing. So let me just give you an example of this formula in action. So number 5 here says, Vanessa just finished her first semester of college. She got a C in her 5-unit biology class, an A in her 3-unit history class, a B in her 3-unit communication class, and a B in her 4-unit math class. What is her grade point average? Now, at first glance, you might think, oh, well, she got a C, an A, a B, and a B. So that should average out to a B, right? Because the A and the C kind of cancel each other and make a B. So you might think, oh, she has a B average, she has a 3.0. But that's not correct, okay? Because not all of her classes are the same units, right? The C that she got was in a 5-unit class, whereas the A that she got was only in a 3-unit class. So really, we're probably going to expect her GPA to be something a little bit less than a 3.0. So to perform this calculation, excuse me, to perform this calculation, an A is worth 4 points towards your GPA, a B is worth 3 points, a C is worth 2 points, a D is 1 point, and an F is 0 points. Now, thankfully, Vanessa didn't get any D's or F's, so we don't have to worry about those. But if we want to compute her GPA, then what we would have to do is multiply what her grade is worth, the number of points her grade is worth, times the number of units of the class that she got that grade in. So in the biology class, for example, she got a C. Well, a C is worth 2 points, and the biology class is 5 units. So we'll do 2 times 5 for the biology class. Okay. For the history class, she got an A. An A is worth 4 points, and the history class is 3 units. So for the history class, that contributes 4 times 3 toward her GPA. I'll let you pause the video and write down what her communication and math classes would contribute towards the GPA. Here's the answer. So her communication class, she got a B. A B is worth 3 points, and the communication class is 3 units. So that's 3 times 3. And for the math class, she also got a B. So again, that's worth 3 points, but her math class is 4 units, so we would multiply that times 4. And that's what her math class contributes to her GPA. Now, we have to divide all of that by the total number of units that she took. Or in other words, the weights, right? She had a 5-unit biology class, a 3-unit history class, a 3-unit communication class, and then a 4-unit math class, right? So that's how we would calculate her GPA. Let's see what it comes out to. So we've got 2 times 5 plus 4 times 3 plus 3 times 3 plus 3 times 4 divided by 5 plus 3 plus 3 plus 4. And as predicted, right, her grade ends up being something slightly less than a 3.0. And that's because the class that she did the worst in, where she got a C, was worth 5 units, right? So it contributed the most towards her GPA. Anyway, so 2.87-ish. Usually I feel like GPAs are rounded to 2 decimal places, right? So 2.87. Okay, and now you know, right? That's how your GPA is computed. Now this can get a little bit more complicated when it comes to like A pluses and A minuses and B pluses and stuff like that. And I don't know exactly, like, I think different institutions, different schools will actually calculate your GPA slightly differently when it comes to pluses and minuses and stuff like that. But I'm pretty sure that like an A plus is not worth more than 4 points. It's still just worth 4 points. And like an A minus is worth 3.7 points, and a B plus is worth 3.3 points or something like that, right? But anyway, that's the idea. Another reason that this is important to you is just, as we said a second ago, your grade in probably every class that you're going to take is going to be a weighted average, right? As we said, tests are going to, generally speaking, be worth more than homework will be. Of course, for different classes, these won't be you won't have these same categories in every class, right? Like, so in some classes you have writing to do and things like that. But anyway, so if you want to figure out what Canvas is doing to calculate your grade, then you have to understand a little bit about weighted averages. So let's look at this example. It's the end of the semester. The only thing you have left to determine your grade is the final exam. Your average grades in each category of the gradebook are as follows. And then we have that chart. Part A says, if you need at least an 80% overall to get a B, what score would you have to get on the final exam to get a B? Okay, well, let's check it out. So what we would want to do is calculate your weighted average, and then we don't know what your grade on the final exam is yet, so we'll just call it X, okay? And so here comes some dreaded algebra, okay? But we're going to do just a little bit of algebra here. But we want your weighted average to be at least 80%. That is, we want your weighted average to be greater than or equal to 80%. So we're going to set up that inequality and solve for X. And that'll help us to know what grade we need to get on the final exam. So here we go. So the weighted average of your grade is going to be the average score of each category times the weight of that category, right? Actually, I think the formula had it the other way around, so let me just try to stay consistent. We'll do the weight times the score. Okay, so that's what the homework will contribute to your grade in the class. The quizzes are going to contribute 15 times 72. The tests are going to contribute 40 times 79. The project is going to contribute 10 times 95. And the final exam is going to contribute 20 times, maybe X is not a good letter because I'm going to get it confused with the multiplication signs I've been using. So maybe I'll just call it F for final exam, right? So 20 times F. Okay. So, and then to calculate your weighted average, we would need to divide that by the sum of the weights, right? So 15 plus 15 plus 40 plus 10 plus 20. And that should add up to 100, right? If this is like, you should have a total of 100% possible. Okay, we need this to be at least 80% if we want to be. So we need this weighted average to be greater than or equal to 80. Okay, so what I want to do now is solve for f. And in order to do that, first I should probably just simplify what I've got. Like, for example, I can do 15 times 87, I can do 15 times 72, and I can add those things together. Right? I can combine all of my like terms. So let's do that first of all. So I'm going to go over to my calculator. We'll do 15 times 87 plus 15 times 72 plus 40 times 79 plus 10 times 95. And then I can't do plus 20 times f because I don't know what f is yet. So we'll just leave that 6495. So we've got 6495 plus 20 times f. And then the denominator, I can also combine those like terms. 15 plus 40 is 70, plus 10 is 80, plus 20 more is 100, just like we thought it should be, okay? And we need this to be greater than or equal to 80. So now if I want to solve for f, the first thing I should do is clear that fraction, right? So I'm going to multiply by 100. Let me see if I can change the color. So I'm going to multiply by 100 on both sides so that those cancel. And now I should have 6495 plus 20f has to be greater than or equal to 8,000. The next thing I want to do if I want to solve for f is get rid of that 6495. So I'm going to subtract 6495. And that should leave, well, so those will cancel now, right? And that should leave me with 20f is greater than or equal to whatever 8,000 minus 6495 is, which I should be able to do in my head, but I'm going to be lazy and use my calculator. So 1505. And then last but not least, if I want to solve for f, I should divide by 20 to get rid of the 20. Now, if you're starting to feel nervous because you're like, I don't understand any of this algebra that you're doing, don't worry about it too much. I'm not going to ask you to do this on a test or anything like that. Okay, but that'll leave us with our final score. So our final score needs to be greater than or equal to 1505 divided by 20, which comes out to 75.25. So if I want to get a B in the class, then I need to get at least a 75.25% on the final exam. So at the end of the semester, you don't have to come to me and ask me this question, because at the end of the semester, I always get this kind of question, right? Mr. Haywood, what can I do to raise my score or whatever? You can figure this out on your own, right? You can figure out exactly what you need to do in order to get whatever grade you want. Part B asks an interesting question. Is it possible for you to get an A? Since you can get a B just by getting a 75, what if you aced the test? What if you got 100% on the final exam? Could you squeeze out an A? Well, let's see. In order to make that happen, we would just repeat exactly what we did in part A, only instead of an 80 here, we would put a 90 here, right? So in order to get an A, you need your final score to be greater than or equal to 90. So if we repeat this with a 90, here, let me put it back to an 80. But I'm just going to do exactly what I did before and replace that 80 with a 90 to see if it's possible to get an A. We would need 6495 plus 20F over 100 to be greater than or equal to 90. Which means we would need 6495 plus 20F to be greater than or equal to 9,000. Okay, which means we would need 20F to be greater than or equal to 2505, which means we would need F to be greater than or equal to whatever 2505 divided by 20 is. 2505 divided by 20 is 125.25. So you would have to get 125% on the final exam in order to get an A. Not possible, right? Not possible, because you can't get more than 100% on a test. So this is not possible. Okay, so you can get a B. In order to get a B, all you need to do is get at least a 75 on the test, but you can't get an A. Okay, well, this might lead you to think, well, then I'm just not going to try. I'm not even going to show up for the final exam. But that would be a mistake. And maybe you're listening to this and you're thinking, that's silly. Nobody would ever think that. Believe me, I've had students who have not shown up to the final exam because they thought, that, well, I'm already going to pass the class. And it's like, no. You still have to show up and take the exam. So, okay, what would happen if you didn't show up to the final exam? Well, then your final grade, I'll just call it your final grade G, it would be 6495 plus 20 times 0. Okay, I'm just taking this expression here and I'm plugging in a 0 for F, because if you don't show up, you get a 0 on the final exam, divided by 100. In other words, that would just be 6495 divided by 100, which would come out to 64.95. So that's a D. Okay, so if you don't show up for the final exam at all, then you get a D in the class, which is not even passing, right? You don't pass the class if you don't show up for the final exam. So you still need to show up, right? You still need to show up and take the final exam. You can get a B as long as you get at least a 75% on the final. But you do need to show up and actually take that exam. Otherwise, you fail the class, right? Which you probably don't want to do. Anyway, so that's how weighted averages work. And that's also how computing averages or centers of measures of center for grouped data works. And hopefully that helps you kind of understand graphs better, helps you understand your GPA better, and so on and so forth. So thank you for hanging in there, and we will check in with you in the next lecture.